Hello, guys. Welcome back to Maths Zone African Motives. We are still on our revisions for our March exams as we are preparing for the tests which we are going to have for our term one. So, in this case, we have an Eastern Cape question paper that we are going to consider. That was Amathole East District. That is term one. 2025 exam. So we are going to consider the previous year question papers as part of revision. So you go through the playlist for March exams and see the ones that are meant for your province, all right? If they are there, then you can work with those question papers which are meant for your province. So without wasting our time, guys, we were given a 2 hour question paper, and that was 100 marks that we have. And as part of your instructions and information, make sure that you read all the instructions and information, all right? So that is the major case here. Our answers, they must be to 2 decimal places unless stated otherwise, all right? Then number the answers correctly according to the numbering system used in this question paper. All right, so just go through every instruction that you're given. And for you to download this question paper, you can check in the comment section, or you can check the description of the video. All right, that can help you to download the PDF so that at least you can see the layout, how it was given as, because here I'm going to present something that can help us to see properly or to view properly, but you can as well download the question paper. All right, so we are given question one, which in this case was on number patterns. All right, I said March exams or the March test that you are going to have depends, guys, with your province. All right, some provinces, they are going to give you those questions which are based on algebra. All right, some, they are just going to focus according to the ATP, meaning to say number patterns, functions, and also the trig, which is your trigonometry. So please do revise as many question papers as you can. All right, so like I said, here we are given a number pattern which is a quadratic pattern. 1.11, write down the next 2 terms of the pattern. So what will be the next 2 terms? We are not given the pattern. They want us to determine the Tn later on. So meaning to say, in order for us to attempt this, guys, we can simply work out the pattern as it is given. Minus 80, followed by minus 63, followed by minus 48. We do understand that as we are working with a quadratic pattern, we must have the first differences and also the second, where the second is the one that is constant or it is common. So we can use that one as an advantage to answer our question, all right? So determining our differences here, that was going to be, this is term 1, term 2, term 3, like that, all right? So that's T2 minus what? T1 minus 63 minus 80. So make sure, guys, you do subtract properly the minus 63. Then what are we subtracting? It is negative 80. So that was going to give us 17. All right, we move on to term 3 minus what? Term 2. In this case, this is negative 48 minus, what are we subtracting? Negative 63. So that was going to give us 15. All right, then in this case, determining the second difference is that's 15 minus what? 17, which is -2. So this is it. With the understanding that the second difference is common, it is constant throughout. It simply means we were going to have that here throughout. We're going to have a -2. We're going to have a -2. We're going to have throughout, guys. That was going to be a -2 throughout. So you can use that now as an advantage to find the terms before. To say, all right, so if here we have got a difference of -2, remember to obtain the next term, we simply have to add the constant difference, 17 plus -2. That was going to give us 15. So again, 15 plus -2, what are we going to have? We are going to have a 13. All right? The same thing, 13 plus -2. If we add this, we're going to have 11. So this was going to continue, guys, and so on. If we add 9 and so on and so on. So we have these terms representing our first differences, which now we can also bring them back here to determine the next two terms. So this, if we add to 13, we must obtain the next term there. So if we add minus 48 minus 48 plus 13, we add 13, that was going to give us what? Negative 35. So we have the term negative 35. This is what we want. So the same thing, the minus 35, if we add what follows here, the 11, we must obtain the next term. So we must add minus 35 plus what? 11. So that was going to give us what? Negative 24. All right, so that's what is going to be the next term from there and so on. If we're going to find another one, we add 9 and so on and so on. But our question is to determine the next two terms. So the next two terms will be what? Negative 35 and what? Negative 24. So those will be negative 35 and what? Negative 24. All right, so that is how these questions can be like just a direct question. So many ways that you can actually play around for us not to have confusion. This is what we can simply use. And also, guys, don't worry about the marks, because whatever that you've used here is a continuation to 1.12 to determine the general term. It's a continuation, so do not worry about that. All right? Be glad because it's just a continuation. So they are saying determine the general term of the pattern, which is the quadratic pattern that we have. In the form, all right, this is right what you're just supposed to know, guys, whether they are going to tell you to say in that form or not. You must understand the format of what? A quadratic. All right, so the nth term for a quadratic, we do understand that's an squared plus what? Plus bn plus c. Where we can determine a, b, and c from what we determine here, the differences, second differences, the first, and the original terms of the sequence. So it follows that this is supposed to be equal to what? To 2a. So guys, we just focus with this part. So that's -2 to what? To 2a. The 17, remember, 3a plus what? Plus b. The T1, a plus b plus c. So guys, this one just have to play around in as much as you can. All right, so let us solve for a. 2a must be equal to what? The second difference. So that's 2a is equal to -2. Thus we're going to have the value of a minus 2, and 2 is what? -1. All right, then determining the value of b. Remember, 3a plus b is supposed to give us what? 17. So that's 3a plus b must be equal to the first term of what? The first differences, which is 17. Since we have a in that case, so it means we can solve for b. That's 17 minus 3a. If we take this to the other side of our equation, all right, so at the end, b was going to be equal to 17 minus 3 times a, where our a is what? -1. So this is it. We can determine the value of b from there. All right, just use your calculator. 17 minus 3 into what? -1. That was going to give us positive 20. All right, so we have got the value of b. To determine c, we can use the first part. A plus b plus c must give us what? T1, which is -80. So that's another equation that we are going to consider. A plus b plus c is equal to what? -80. So with this, we can solve for c. Remember, we have got a and what? And b. From what we solved before, we have got the value of a, we have got the value of what? Of b. So since we have got these two, simply make c the subject of the formula. That is c is equal to what? -80. A to the other side is going to be minus a. B to the other side is going to be minus b, so that we can simply substitute, guys, what we are given. In place of a, it is what? -1. All right, so in place of a, that's -1. And in place of b, our b is what? That's 20. Just like that. So you are going to have the value of what? Of c, by substituting a and b into our equation. -80. All right, -80 minus, what are we subtracting? -1, minus 20, like that. That was going to give us -99. Okay, so we have got the value of c, which we can substitute now all these into what? Our Tn formula. So therefore, in our case, the Tn was going to be equal to what? Remember, an squared. Our a, that's -1, so that's -n squared plus b, and our b is what? That's 20. And our c is what? Negative, so it was plus minus, like this. So it was going to give us what? -99 at the end. Just like that. So this is the general formula that we are going to use to attempt any other question, as long it is to be from the general formula of the quadratic. All right, so that is how they ask these questions. Then we are given on 1.13, between which two consecutive terms, the terms that are following each other, term 1, term 2, like in that manner, between which two consecutive terms of the quadratic pattern will the first difference, the first difference be -1, 0. The first difference is the one that is being referred to. So as we are to consider the terms there, we are saying which term is it? T1 and T2? Is it T3 and T4? Is it T5 and T6? But they are from where? From the first differences. Remember, when you dealt with this quadratic, we have got the first differences here and the second difference. So they are saying from the first differences, which is what? 17, 15, 13, 11, and so on. These are the terms that we are given for the first what? The first differences. So if we are to consider that we are dealing with these, what is it that we are having from the first differences? We are having an arithmetic sequence. is we are to see the difference. Remember, guys, let's say this is your sequence. Forget about this, guys. Forget about here. Forget about these terms that were given before, because those ones were for a what? A quadratic. From the original quadratic that we had, that is what we had. But they're saying from these first differences like this. So if you are to consider your terms now, this will be your first term, your second term, your third term, and so on and so on. What type of a sequence is it that you're actually having? This is an arithmetic, because the difference is there is the same, which is what? Your constant difference of -2. So you're dealing with an arithmetic. So that's on 1.13. We are dealing with an arithmetic where Tn for an arithmetic is given as what? A plus n minus 1 times d from our formula sheet. So we can determine that and equate to the Tn that we are given, because they told us that the term must be what? Must be 103, negative 103. So what is going to be the n now from there? We need to calculate or to determine n. We are dealing with an arithmetic sequence. Remember that. So meaning to say we can determine our Tn, A being the first term, our T1, we have that one. D, the difference, which is what? -2, we have that one. So you can simply substitute Tn is equal to A, the first term, 17, plus n minus 1 times d, which is our difference of what? -2. So that was it. You were going to simplify. Here, let us expand the brackets. As we can see, we have got this -2, which is to expand everything in that bracket of what? N minus 1. All right, so that's at the end. Tn is equal to 17, -2 times n. That was going to be -2n, -2 times -1. That's a +2. All right, so this is it. We can have our Tn in simplest form, -2n. Then we collect the like terms. In this case, there is 17 and what? And 2. These are our like terms. So adding this, that was going to give us what? 19. All right, sorry for that, +19. So this is it. We have the Tn from an arithmetic, which is the same that they are saying it is equal to what? To -103. Those two guys, they represent the same thing, only that one is given as a numerical value, one is given as an expression. So since Tn is representing the same thing, therefore equate them. So therefore, we're going to have -2n plus 19 being equal to what? To the same Tn that we are given as a numerical value, -103. From there, we can solve this equation for what? For n. All right? So that's it. Okay, to get rid of this is a linear, guys. So it's simply subtract the 19 here. Both sides, that was going to cancel. So -2n is equal to -103 minus 19 was going to give us -122. All right, -103 minus what? 19. So that's -122. So to find the value of n, simply divide. This is a product, so divide by what? By -2. That was going to give us a +61. So remember, they said between which two consecutive terms following each other. T2, T3, like that. So from this n, which is equal to 61, it means we are referring to T61. Followed by what? The next term is what? 62. So that's T62. So it's going to be between these two T61 and T62. Those are consecutive terms. Okay, so as we can see, guys, it's just more of a repetition. We have dealt with these typical questions, but it's exam, it's a test. Do revise as many questions to understand how are they going to ask. All right, just try to play around as many questions as you can. All right, so that was it on question 1.1. 1.2, consider the following sequence. All right, they gave us, all right, these exponents, guys, it's geometric there, but anyways, they actually mentioned about that. 1.21, for which values of p will the series converge? All right, so for this to converge, remember the properties, guys, on 1.21. For us to have a convergent series, R must be greater than -1, but less than 1. R being the common ratio, the constant ratio, which we do not have. But from these terms, T1, T2, T3, we can determine that because R is simply T2 over T1, the T of n over the T of n minus 1. So it can be T3 over T2 and so on. So in our case, we have the T2. So we simply substitute that, which is what? 8 into p minus 3 to the exponent of what? Of 4, all right? So if we were to substitute this 8, that's into p, all right? Let me just do it here. P minus what? Minus 3 to the exponent of 4, everything over T1, which we are also given in our case, all right? Sorry, this is our T1. 16 into p minus 3 to the exponent of what? Of 3. So we're just going to substitute that one. That's 16 into p minus 3 to the exponent of what? Of 3. All right, so here we are back to some of our exponents concept, right? But anyways, let's start with the numbers. 8 into 8, 1 into 16, that's 2. These two brackets are the same, so it's just like x to the exponent of a over x to the exponent of b. We do subtract exponents a minus b, so it was going to be 4 minus what? 4 minus 3, which is what? Which is a 1. So we're going to remain with the p minus 3 to the exponent of 1 over what? Over 2. So that's it, p minus 3 over what? Over 2. Remember, anything to the exponent of 1 remains as it is. So this is our r there. Remember, the question is for which values we must solve now. We must solve for what? For p. Since our r is in terms of p, we have got p here. We are going to solve for that p. From the inequality that we have, our r is what? P minus 3. So p minus 3 over what? Over 2. That's our r there. Is supposed to be greater than -1. But the same p minus 3 over 2 is what? Is less than 1. So let's solve. That one is going to give us what? It is going to give us the possible values of r as part of our inequality, all right? So let's get rid of the denominator first. There is a 2 here. This is a whole number, so that we're just going to consider that 2. So to get rid of this, we must multiply by what? By 2. But whatever that you do here must be done on the other side of the inequality and also on the other side of the inequality. So you have to multiply by 2. Negative, so here, sorry, this was going to cancel and you remain with what? P minus what? Minus 3, which is greater than -1 times 2, that's -2, and less than 1 times 2, that's what? That's a 2. So in order for us to get rid of the -3 affecting our p, we simply have to add 3 here. So to add 3, whatever that you do here in between these two inequalities must be done over the other side of what? The inequality. So simply add a 3 here add a 3 there. So that is it. Our P was going to be determined. So we're going to have P as what? A value that is greater than negative 2 plus 3, which is what? Which is 1, but less than 2 plus 3, which is what? Which is a 5. So P is supposed to be within this interval, a value that is greater than 1, but less than what? But less than 5. Just like that. All right, so that is it. Then 1.22, calculate the sum to infinity if P is what? 3,5. And for sure, P can be 3,5 because P is greater than 1 but less than 5. So it can be 3,5. So the value of P that we are given there, truly it does make sense, all right? Not to say we calculate something, then they will give us a certain value of P which does not even satisfy that interval. It shows that something is wrong on our calculation. But in this case, everything is fine. So they said calculate what? The sum to infinity. We are given this formula from our formula sheet. Remember, that's the sum to infinity is A over what? 1 minus R. A being the first term, T1. A being T1. So we have got this T1, but it is in terms of P. R being the common or constant ratio is also in terms of P. So thus, we're going to need to calculate these first to obtain the numerical values, because we have got these guys which are in terms of P. Our A so remember that's T1, 16 into P minus 3 to the exponent of 3. So with the value of P that we are given as 3,5, we were going to put that or substitute that 3,5 in place of what? In place of P. So doing this, guys, that was going to give us, let us put back here. So A is equal to 16 into P. Remember they said P is what? 3,5. So that's 3,5 minus 3 to the exponent of what? Of 3. So you can even leave it as it is like this, or you can find the exact value, the numerical value from there. All right, let's just find the numerical value. 16, open bracket, 3,5 minus what? Minus 3, everything to the power or to the exponent of 3. That was going to give us a 2. So A is equal to what? To 2. We have got the value of A to be substituted into our formula. Our R is there, but it is in terms of P again. So we must find the exact value by substituting what? The value of P. Our P is what? 3,5, remember? So that was going to be 3,5 minus 3, everything over what? Everything over 2. So that is it. By substituting the value of P, determine this, we're going to obtain that's 3,5 minus 3, everything over 2. And that was going to give us 1 over 4. So we have got the value of R there, which we are going to substitute into the formula. The numerical value is the one that we need. So simplifying this, therefore, the sum, we're going to have the sum to infinity as what? A, remember numerically is what? That's a 2 over 1 minus our R, which is what? 1 over 4. So that's, we have got the sum to infinity. All right, so this is how you simply answer these questions, guys. 2 over what? So that's 2 over 1 minus 1 over 4. And that was going to give us 8 over 3. So we have got our sum to infinity as 8 over 3. You can even have it as a decimal, 2,66 and so on. You can have it as a mixed fraction, 2 and 2 over 3. All right, so that is how to attempt these typical questions. You just needed numerical values. All right, so that's our 1.2, marking the end of question 1 with 12 marks. All right, so that was our question 1 at the end. On question number 2, we are given 2.1. The sum of the first n terms, the sum, take note, they gave us the sum in terms of n. It is given by Sn is equal to 4n squared plus what? Plus 6n. So this is what we are given. And on 2.11, determine the first 3 terms of the series. Guys, we're talking about the terms, T1, T2. This is what we need. T1, T2, T3, the first 3 terms. So if we look into our question, we are going to notice something that is important also as an individual. If you're under exam, some of these are important to note. Remember, I said that if you are to determine the nth term from the Sn formula, it is to be taken as Sn minus S of n minus 1. So terms can be determined, meaning to say T1 is equal to S1. That one, you take it as it is. But T2 is going to be in place of n, it is going to be S2 minus here 2 minus 1, which is what? S1. T3 is going to be determined. Our n is 3, so that's S3 minus, in place of n, 3 minus 1, that's what? That's 2. So you are going to need this, guys, which is fine. You can just substitute into the formula. S1, it means in place of n is 1. S2, it means in place of n, you can do that. But noticing that there are so many things to be calculated, we can simply evaluate that Sn formula, the Tn formula. Also, if you check, there's something here about the last term of the series is 58. How many terms are in this? How many terms? They're talking about the last term. So definitely they also wanted you to have the Tn formula in terms of n at the end. So calculating these from this part was okay. But what I'm just saying, it was wise enough for you to just calculate what the Tn formula first to determine it. Then calculate these values later on. It was wise enough. So let's determine Tn in terms of n. Tn in terms of n. It's Sn as it is given, 4n squared plus 6n minus. S of n minus 1 simply means now in place of n, put what? N minus 1. Wherever we see n, we are going to put what? N minus 1. So there is an n there. So it's going to be 4. In place of that n, it is going to be n minus 1 squared plus 6n. In place of n, it's going to be what? N minus 1. All right, like this. All right, no problem, guys. I'm going to use these ones also to show you guys it's just one and the same. But yeah, it was advantage so that on question 2.12, you just answer the question. Now you don't need to calculate this one again. But anyways, guys, it's exam. You can answer the way that you understand at the end of the day. So this is it. Our Tn was going to be 4n squared plus 6n minus. The minus that we have must expand this bracket. So there's minus, which is going to multiply 4. So that's minus 4 into n minus 1 squared. The minus is going to multiply the positive 6. So it is going to be negative 6 into n minus 1. We have expanded each term by that negative. Then expand the brackets. That was going to be 4n squared plus 6n. Here, there is a bracket that we must consider of n minus 1 squared. So this one, guys, we're not supposed to worry about it because we do understand that a minus b squared is equal to a squared minus 2ab plus b squared. First term squared minus 2 times first and last terms what? Plus the last term squared. So meaning to say here it was going to be negative 4 into what? N squared, our first term, our last term. So that's n squared minus 2ab, that's 2 times these 2 times n times 1, which is 2n, plus b squared, the last term squared. 1 squared is what? Is 1. So expanding by negative 4, this bracket, we were going to have now negative 4 times n squared, negative 4n squared. Negative 4 times this negative 2 plus positive 8n. Negative times a positive 1, negative 4. So we have expanded everything now. Be very careful. All right, then we move on to the last bracket, which is the n minus 1 expanded by the what? The negative 6. So negative 6 multiplies n, negative 6n. Negative 6 multiplies the negative 1, it's going to be positive 6. All right, then we can collect like terms. Where there are like terms, collect your like terms and what? And simplify further. So in this case, 4n squared minus 4n squared, that was going to cancel. We also have 6n here and 6n. These two we're going to cancel. So meaning to say I'm just left with, in terms of n, it is just this one, 8n. So that's going to be 8n. All right, for the numbers, we have got the minus 4 and the 6. Minus 4 plus 6. These two, they are remaining. So minus 4 plus 6 is what? Is positive 2. So that was going to be a positive 2 like this. This is our Tn, guys. Tn represents the nth term. This is the general formula for terms. For terms. So if the question now is saying determine these terms, from this we can determine those terms, which is what? The first 3 terms can be determined because you're just substituting now to say the first 3 terms, T1, in place of n, you put a 1. So it's 8. It's going to be 8 times 1 plus what? 8 times 1 plus 2. And that was going to give us what? A 10. The same thing for T2, first 3. We need 3 terms. T2, in place of n, you put what? 2. Then simplify. 8 times 2 plus 2, that's 16 plus 2, which is what? 18. T3, in place of n, is going to be 3 this time. So that was going to give us what? 26. So therefore, the first 3 terms of that sequence will be 10, 18, 26. Just like that. From the Tn formula, you can determine those. But for those who are used to the Sn formula, you are not limited. Here I was just in caution because of what? 2.12. There was no way we have to go back to calculating, determining of this. So it was important that you just find that one. Just like that, all right? Or you can simply use the Sn as it is. Remember, I said you can determine these terms from the Sn as it is. So therefore, T1, remember T1 is same as S1. So meaning to say in place of n, just from Sn formula, just put as it is. 4 times 1 squared plus 6 times 1. And that was going to be 4 plus 6, which is what? Which is 10. All right, then T2. All right, so for T2, we must find S2 first because we are saying T2 is going to be S2 minus what? S1. S1 is there, but we do not have S2. So let us just find S2 first. In place of n, you put a 2. So that's 4 times 2 squared plus 6 times 2, which was going to give us what? Okay, let's simplify it and see. 4 into 2 squared plus 6 into 2 like this. That was going to give us what? 28. So since we have S2 and S1, we can find T2. All right. So therefore, our T2 was going to be what? Our T2 from the formula S2 minus S1, S2 minus S1, that will be S2, 28 minus S1. Remember, S1 is T1, which is what? Which is 10. So that was going to give us 18 at the end. All right. So we've got our T2. To find T3, same thing. S3 minus S2. S2, we calculated this, but we do not have S3. So you're supposed to find S3 first. S3, it means from the sum formula, substitute 3 there. So that's 4 into 3 squared plus 6 times what? 6 times 3. In place of what? In place of n, put 3 from the sum formula. So if we're to evaluate this, we're going to determine the sum of the first 3 terms. So that's 4 into 3 squared plus 6 into 3 like this. All right, that was going to give us 54. We have the sum of the first 3 terms. So therefore, to determine T3 is going to be easier now, because we do understand that our T3 is simply S3 minus what? S2. The T of n is equal to Sn minus Sn of 1, minus 1 here. So we have these two. Substitute. So therefore, T3 is equal to S3. That is what? 54. Minus S2. Remember, we calculated our S2 previously. It was what? 28. So this is 54 minus 28. And that was going to give us what? 54 minus 28. And that was going to give us what? 26. So those are the terms. All right. Those are the terms that we're going to have at the end. 10, 18, and what? 26. As we can see, these are the same answers that we obtained from the first attempt that we had. So it's up to you guys. This is another way that you can actually choose to use or to work with. All right. So let's answer, guys, as many question papers. Do as many question papers you figure out. It is just a repetition throughout. All right. They do repeat these questions. The last term of this series, or of the given series, is 58. How many terms are in the series? The last term. So in order for us to attempt this is 2.12. Remember, whenever you're given or told about the last term, it is simply your Tn. The last term, L, represents Tn from the general formula, from the Tn formula. So they are saying Tn is equal to 58. That is what they are simply saying. Tn is equal to 58. So how many terms are in the series if Tn is 58? So you were going to find Tn now using this concept. Tn is equal to... So you see, guys, there was no way of running away from this. That is why I had to actually do this in 2.12, in 2.11. As we already have this, but if, let's say, you did not use this in the first place, you're going to calculate, determine this Tn, then use it now to find the value of n, because what we need there is the number of terms n. For the same Tn, which is numerically given as 58, here it is given as what? 8n plus 2. So therefore, we are simply saying these two, they are equal. 8n plus 2 is equal to what? The tn given numerically as what? 58. You have an equation that you can use to solve for what? For n. So 8n is equal to what? Subtract 2 both sides of our equation. That was going to give us 56. All right, so that's 56 divided by 8 by 8. So therefore, n is equal to what? 7. So we are talking about 7 terms in that case. All right, that is what we have. So you see how they play around with you guys. We have that one. All right, then 2.13, write down the series in sigma notation. Remember the series taken from what? From Tn. Again, you need that Tn again, guys. In sigma notation, we can simply use this part 2.1, 2.13. Remember, in sigma notation, Sn is equivalent to the summation of Tk from k is equal to 1 up to n. All right, so you can simply use that because they told us that this is the sum of terms, So it is the summation from the Tn that we calculated this one. Remember, we've got the term presentation, the general term. This is Tk for the general term. So that is, you just use the general term as it is 8 what? 80k in place like Tk. So it's going to be 80k plus what? Plus 2. From what? From k is equal to 1. But here we also have the number of terms. We know that we are given, because we calculated that there are 7 terms. N is what? 7. So you can even use the last term, or you can just put n there to represent taken up to n. It is one and the same. They're still going to give you full marks for that. All right. So summation, guys, you are saying sum of terms. So you use Tn, or in place of that Tk. All right. The terms, the terms, the Tn, but that's your Tk, just like that. So for this one, I don't think you're going to have a lot. Let's consider 2.2. The sum of the first 5 terms of a convergent geometric series. A convergent geometric series is given. So they told us the sum of what? First 5 terms is what? 62. And the sum to infinity. The sum to infinity of the series is what? 64. Determine the common ratio. All right, there are 2 things that we are given here on 2.2. First, the sum is a convergent where r is greater than -1 but less than 1. So for the sum, for the sake of revision, guys, the sum, there are 2 formulas. The one that you're given in a geometric A, r to the exponent of n, the one that you have in your formula sheet. If we are going to use this, it's fine, but also take note. When you have to calculate the sum to infinity, the layout of the formula 1 minus r. Remember, I told you guys about the formula SNA into 1 minus r to the exponent of n over 1 minus r, which is best to use if our r is less than what? Less than 1. And our r in this case is less than 1. So you can actually use this formula, and also with this presentation, that same denominator, we're seeing that it is the same. This one is r minus 1, this is 1 minus r. So it's up to you. But anyways, for those who are used to the formula sheet, I'm just going to maintain that formula that you're given in your formula sheet, all right? For the S of n, sum of what? The sum of first 5 terms. So what is the sum of the first 5 terms? That's 5 there in place of n is equal to A. We do not have that one. R, we do not have that one. We just have the number of terms 5 minus 1 over what? R minus 1. So that is what we are given, that this is equal to what? 62. So that's equal to 62, which is an equation. So you can just leave this one. and equate to what? 62, like that. So it's an equation that we have formed. What about the sum to infinity? Before we can move on, okay, this is our equation 1. From the sum to infinity, a, so it's going to be a over what? 1 minus r. We do not have anything here. A, we do not have, r, we do not have. So that's a over 1 minus r is equal to what? We are given it as what? As 64. So these are two equations. But since we are to calculate the common ratio, which is r only, we can get rid of the a because there is a here, there's also a here. So we can make a the subject from one of these two equations and substitute into the other equation. So in my case, I'm going to use this equation 2, this equation that I'm having here, the second equation. Let me make a the subject, all right? Make a the subject. Since we do not need that a, so make it the subject. So therefore, a, this is same as over 1. We can simply cross multiply here. 1 times a, that's a, is equal to what? 64 multiplies what? 1 minus r. So it multiplies 1 minus r like this, okay? So this is our a. From this, we made a the subject. So I'm just going to call this equation 2. So where I have a in equation 1, I'm going to put this 64 into that bracket. So simply substitute our equation 2 into what? Into equation 1. So that is in place of a, put this part. So it was going to be 64 into what? 1 minus r in place of a. Then this remains as it is, r to the exponent of 5 minus 1, everything over what? Everything over r minus 1 is equal to what? 62. Guys, we have an equation on its own, which is in terms of r. Solve for that r now. How? How is that possible? So that is why I was explaining about the two formulas before for the sum of terms. Because if you check here, there's a condition where we need to cancel, but these two, they're different. This is 1 minus r. This is r minus 1. Remember the a minus b concept that you had in your grade 11 to say, if it is equal to a certain part, whatever that you're going to have, it is either we can factor out the negative that we have and it will be b minus a. It is one and the same. Nothing has changed. So the a minus b, when multiplied by a negative, changes to b minus a. So what am I trying to say? If I'm given 1 minus r, let's say I want to change, here you can change anyone. So let's say I want to change 1 minus r to be like this, r minus 1. 1 minus r is the same as, if you factor out a negative, it was going to be negative 1 plus r, which is the same, guys, as what? R minus 1. So in order for us to have same, we must factor out a negative there. So this here, guys, be very careful. For you to cancel these two, you must introduce a negative because they are not the same. Unless if you're having same brackets, all right? So it was supposed to be negative 64. These two brackets are now the same because here we now have what? R minus 1. This negative here is the one that I put there. So that's R minus 1 into r to the power of 5 minus 1 over what? R minus 1. We just wanted to have these two brackets to be exactly the same so that we can cancel. So what I was just saying is that when you see this condition, for you to cancel here, just introduce a negative, all right, under exam condition, but we saw where it was taken from, all right. Anyways, this is where we are. We can solve for this. Here we are left with negative 64 into r to the power of 5 minus 1, which is equal to 62. So simply divide by negative 64 since we have a product there. So that was going to cancel. And we have got r to the power of 5 minus 1, which is equal to what? That was going to be negative there, 62 over 64. All right, we can just leave it as it is, 62 over 64. That's 31 over what? 31 over 32. So it's negative 31 over 32. Remember, there's a negative. So there is r to the exponent of 5 plus 1. The minus 1 there is just separate from this, guys. It's different from r to the exponent of 5 minus 1. Like, no. This is a separate thing. The minus 1 is on its own, so you can get rid of this by adding what? Both sides of our equation. So we're going to remain with r to the exponent of what? 5. So r to the exponent of 5 is equal to what? We can add these two. That's negative 31 over what? Over 32 plus what? Plus 1. That is going to give us 1 over 32. All right, so we've got 1 over 32 there. 1 over 32. So remember, guys, if you're given an exponent, to get rid of that is going to be the nth root. From x to the exponent of n, we introduce what? The nth root. So this is 5, meaning to say the fifth root. This is 5, so the fifth root. The same here, the fifth root. So we need that to neutralize this 5 and 5. We're going to remain with what? With r there. So our ratio, common ratio r, is equal to the fifth root of what? 1 over 32, which is 1 over 2. All right, on our calculator, the fifth root, we are going to need this one on x to the exponent of this one, the one that is on top. So it's shift to press to get rid of that, or to press that one. So that's shift. Okay, so the fifth root of what? 1 over 32. So this is 1 over 2 at the end. All right, so that is how these questions can actually be given, as it is just a matter of playing around with more questions. Do revise as many questions as you can. All right, it's a matter of playing around with more questions, as you can see. Equations, also solving of equations. There are two equations, two unknown values, but they said calculate this, so you can take advantage. Okay, since it is about only the common ratio, so let me just get rid of the a there, then substitute that in place of a with what? With r, so that we just focus on what? On calculating r. All right, moving on to the other part of our question, which is 2.3. They gave us a condition which is still on our number patterns, but this time with this finance concept. All right, we are given that Kanya FM is a community radio in Butterworth, and had a competition where the prize money is awarded over a period of what? 5 days. The number of days is what? 5. On the first day, 5,000 rand is given to the winner. 5,000 on the first day. All right. Then on the second day, 80% of that prize money was awarded to the winner. 80% of that prize money. And so on. All right. So it was that and so on, such that the prize money continued to be 80% of what? Of the amount awarded on the previous day. 80% of the amount awarded on the previous day is given to the what? Is given to the winner of the day. So this is the condition of what is happening here? The first day, the winner got what? 5,000 the first day. This is what is happening. The first day, the winner got 5,000 Rand. That's our first day. The second day, the winner is getting 80% of that prize money, and it continued like that to say it's 80% of the day before. So meaning to say, to find T2 is simply 80% of T1. The day before, so 80%, 0.8 or 80 over what? 100. This is 80%. Of what? What we got before, 5,000. So meaning to say the following day, the prize money that was awarded was going to be 4,000. And so on and so. So this happened, guys, the third day representing our T3. So meaning to say T3, it's 80% of the previous one, which is what? T2, the previous day. 80% of this is what? 3,200. So it continued in that manner throughout. It continued like that. This is what they're explaining on that statement. It was for 5 days, remember? Then, all right, let's answer the question 2.31. How much money is given to the winner? On the fourth day, how much? So we need T4, the term 4. That is what we simply need there, guys. We have T1, T2, T3, and so on and so on. So what is our T4? The next term from what we have, T5, and so on. Remember the concept 80%. So T4, 80% of the previous day, T3, 80% of that. From what we had, multiply by what? 80%, 0.8. That's 2,560. Just like that. 2,560 Rand. This is the money that was being awarded on the fourth day. Just like that. You see, guys, it's just playing around with questions. Playing around with questions. All right? 2.32. How much money is given out by the station over the what? The 5 days. So, guys, over the 5 days, we can simply use the formula or just add them. Or simply add. Because the 50th day here, we can even tell, okay, the 50th day, that's T5. We are almost there. So just calculate what? 40% of that. 40%. 80%, because they said 80% times 0.8. It was going to be what? 2,048. 2,048. So if I'm going to add this, because these are the 5 days, remember, for 5 days. So I add 5,000 the first day. The second day, they gave someone 4,000. The third day, they gave someone 3,200. The fourth day, they gave someone 2,560. And the fifth day, they gave someone 2,048, giving or amounting to 16,808. So we can simply sum up how much, the sum up everything, T1 plus T2 and so on. You're going to get 16,808. Or use the formula. Or simply use the formula in our case. These terms, guys, obtaining 80%, we are saying to get the next term, it was 80% of the previous term. That is what? That is our ratio. This is geometric. Multiplying to get the next, you are multiplying to get the next, you are not adding, you are not subtracting, you are multiplying. So mean you say you're talking about what? A geometric sequence that we have. So if it is a geometric, the sum of terms was how much it is the sum, the total. They simply say calculate the sum of terms. This is what they just are asking you. Calculate the sum of terms. How much do we have after 5 days when n is equal to 5? Our a being the first term, we have it. What is the r? So r is that percentage that we are moving from 1.80%, or you can simply use T2 over T1 formula. Our T2 over T1, that's 4,000 over what? Over 5,000. So that was going to give us 4 over 5, which is what? 0.8. The 80% as a decimal is what? 0.8. So with this, we can calculate the sum. That's how much they gave in 5 days. So S5, N is 5. A, the first term, 5,000 into R. Our R is what? 0.8. To the exponent of n, the number of days, 5 minus 1, like this. Everything over r minus 1. So everything is over 0.8 minus 1. So you can just simplify this on your calculator as it is. So that is the sum for these 5 days that they had the competition. So put a fraction, 5,000, open bracket, 0.8 to the exponent of 5, then subtract 1. Everything is over what? 0.8 minus 1. So that was going to give us 16,808, as we can see, the same answer as before. All right, 16,808. So this is the sum that was being awarded in what? In 5 days. They're simply saying calculate the sum. Just like that. We can use that, or in that case, we're going to simply add, as we have got your terms there, it's simply add them. All right, anyways, we might need these terms. Let's just leave it. 2.33. If Kenya FM has 22,000 Rand to give out for this competition, all in all, that's what they have. Over how many days would this competition last before there is no more money to be awarded? Remember, they are working with percentage. So the 22,000, guys, this one, it is the money that they have for them to award the people. All right? So meaning to say, whenever they are to award, they are limited to that amount. They are limited to that amount, all right? 2.33, let me put it this way. They are limited to that amount. That is the case. So if they are limited, it means the sum, which is our Sn, is less than, or it can be equal to 22,000. That is the case. You cannot give more than what you have. That is the case. You can only give to what you have, or less than what you have. Less than what you have, or up to what you have. Not to say you don't have that, guys, then you want to give. How is that possible? You can give all or less of what you have. But in our case, they want us to use everything, this whole amount. So they are going to use everything, but we want to know for how many days now. So it's an inequality. From the sum of terms that we had before, we are going to now consider it being less than this. So remember our Sn formula, guys, we had this one. That's our a into r to the exponent of n minus 1 over r minus 1. That's less than or equal to 22,000. All right, let's try to solve it for our a being what? Remember the a, guys, we had this as our first term. Our a is what? 5,000. So we can substitute that one. 5,000 into our r, that's 0.8. But we do not know the n now for how many days, to the exponent of n. Minus 1 over what? 0.8 minus 1 is less than or equal to 22,000. That's what we have there. We have formed an inequality. We can use up to that amount or less than that amount. All right, so let's see what happened. So for what? For n. All right, so yeah, there's so many things, guys, to consider. So many things to consider, actually. But do not panic. We can just divide these two. 5,000 divided to this and see what's happening there. All right, let's just focus on those two. Solving here, guys, it's in your hands. You can play around the way that you want. So if I'm to divide these two, 5,000 over what? 0.8 minus 1, that is going to give us negative 25,000. All right, negative 25,000. Negative 25,000 into what? That's 0.8 to the exponent of n minus 1, which is less than, guys, or equal to what? 22,000. All right, I need something here inside, so get rid of this negative 2,000. Negative 25,000, this one. Let's divide by it. But remember, we are dealing with an inequality. The moment we divide by a negative value like this, the inequality sign reverses. We are dividing by a negative, so it affects the inequality sign. It must reverse. All right, so thus we were going to remain with 0.8 to the exponent of n minus 1 being less than or equal to, sorry for that. Remember, I'm saying this must reverse and I'm doing something else here. Greater than or equal to, it changes. We divided by the what? The negative, so that must change. So that is going to give us negative, okay. These guys is going to cancel, so just negative 22 over 25 there. Okay, you can just use your calculator as well. All right, on the left hand side, remember we need n. There is a negative 1 which is just being subtracted from the whole of this part. So let's get rid of it. Add 1 both sides. So this can cancel. You've got a 0.8 to the exponent of n, which is greater than or equal to, we simplify this part. So simplifying that, negative 22 over 25. All right, then plus 1. That was going to give us 3 over 25. All right, 3 over 25, which is same as what? 0.12 as a decimal, 0.12. Okay, this is where we are, where we could just determine the critical values and so on. But in this case, since we are dealing with, we are not going to have like those quadratic where there are so many solutions. It's just one. So there's no need for you to determine critical values. Solve as even as it going down, as it is. There's no critical value condition there, because you simply have one value. So how do we get rid of this? Because our n is on the exponent, and these denominators, guys, cannot even be the same. We cannot even equate. So we can introduce logarithms. Remember, if I introduce a log, I introduce a log here. What happens? I will drop the exponent where there's an exponent from the laws of logarithms. The logarithm of a to the exponent of n is n log a. So we're going to drop the exponent by introducing that. So it will be n log 0.8 greater than or equal to the log of what? 0.12. But be careful as you deal with the logarithms. The log of 0.8, log 0.8, like this. See, guys, it's a negative value. The log of a decimal, this is a negative. So this whole part that we see here, it represents a negative value. So the moment you are going to divide to get rid of that log, you're going to divide by the log of 0.8, the log of 0.8. take note of what you are using on your division, a negative value. So dividing by a negative value, just like what we saw here previously when we divided by this negative. It's only that here we can see it's minus, it's written minus. But it's a negative value. Here it's not written a minus, but if you simplify it, it's a minus. It's the same as you are dividing by minus 0,096, the way that is given there. So what are you dividing with? A negative value. The inequality sign must reverse, must change. So this one changes because of that. All right, so it must change. So that is it, guys. Here, this inequality sign changes. It's no longer a greater than, it's now less than. So n is less than or equal to what? We can simplify the right-hand side. The logarithm, all right, let's have a fraction. Log of what? 0,12 over what? The log of what? 0,8. So that was going to give us 9,5 0 and so on, 9,50 and so on, which is what? 9,50. 9,50. N is less than 9,50. This is 9. This is 9,5. So we are saying less than 9,5. Less than 9,5. So the whole number that we're going to have is what? Is 9. So we're talking about number of days. Number of days. How many days? 1, 2, 3. Like terms. Term T1, T2, T3. So therefore, n is equal to 9. That is for 9 days. That is the case. That's for 9 days. They're going to have, they can last, their competition can last for 9 days. So for 9 days, they have used almost their money, because the following one, we can see there's the following day, that was not going to be 80% of the previous day. It was not going to reach that amount. So on the 9th day, they can say their competition is done because of what? They've reached that amount necessary. So here the concept was on solving here, the solving part. Introduction of the logarithms, where there's an exponent 2 to the exponent of x is equal to, where these cannot be related to the same base, introduce log. Just put log, or you can put the natural log, ln. X log 2 is equal to log 3. By then, you can just divide by log 2 both sides. This cancels. You have got your x as log 3 over log 2. Just like that. These are some of the equations that you must be able to use in your simplification. So 2.33, that was it. Yeah, they ask these questions. These ones, they do ask them. Revise as many as you can. All right, that was it for question 2. We're having a total of what? 18 marks. We have already completed question 2. Moving on to question 3, which was part of your functions. We are given f of x as part of our functions, 1 over 3 to the exponent of x. From that f of x, there is a point which you are given, minus 1, 3. They never explained, but they just gave us that. Nothing much. Then questions, 9 marks for that. All right, anyways, let's answer, guys. From that part, write down the domain of what? The domain of f, x values. Are the x values affected here? No, they are not. X can be any value that we think of. Not even affected. So our x can be taken from negative infinity up to what? Up to infinity, meaning to say x is simply what? A real number, any real number that we have there. Then the range, the y values, they are affected. As we can see, the x-axis is our asymptote. Y is equal to 0. It's our asymptote, meaning say the graph is above. The x-axis above y is equal to 0. The graph cannot be found at y is equal to 0 or below. So meaning to say, as part of our range, We are simply saying y is supposed to be greater than 0, bigger than 0, above the x-axis. All right. Another part of our question, we are now given, write down the equation of what the inverse, guys, in the form y is equal to this, the inverse. So how do we determine the inverse? Already we have got our f here. So to determine the inverse, remember, that's y is equal to 1 over 3 to the exponent of x. The first thing is to interchange x and y. We must interchange them. So meaning to say x is equal to 1 over 3 to the exponent of y. Then we make y the subject of the formula. To make y the subject of the formula, just remember your logarithms, guys. The logarithm of a in the base of b is equal to c. It follows that this a here is equal to b to the exponent of c. A is equal to. So we are given in this format. It simply means the logarithm of what? It's what? It's x. The base b is our base here. What is our base? 1 over 3. This is our b. So this is our a, this is our b. 1 over 3. In the base of 1 over 3 is equal to y, which is what? Which is our c, the exponent. So y is the subject there. Y is equal to the logarithm of what? Of x in the base of a third. We have got the inverse. Remember they said write it in the form y is equal to. Then you draw the graph of the inverse in your answer book. Show clearly the what? The intercept with x as well as the coordinates of the other point, all right? The inverse is the graph of a log. So we can use the one that we already have here. Remember, we already have here this one. So remember the inverse is the graph that was drawn from what? It was the graph that was drawn after a reflection in the line y is equal to x. After a reflection in the line y is equal to x, a reflection was what? I mean the mirror line being y is equal to x enabled us to have this logarithmic function. This is the concept. So that is something like this. All right. This graph here was crossing or passing the x-axis at what? At 1. So, I mean the y-axis, sorry for that, guys. The y-axis at 1, the original function. So this is our original function. It was like this. Crossing the x-axis, I mean the y-axis. Why am I repeating this, guys? I want the x-axis. So meaning to say when reflected in the line y is equal to x, it's going to be here. All right. So you just need to break for 5 minutes, then continue. I think it's going to help me. All right. So it's going to be reflected to over this side. That's another point that you can actually work with. And another point is the reflection of the point -1, 3. Remember, in the line y is equal to x, you simply swap the values, the coordinates. So you swap them. So meaning say on the image, which is the log graph, we swap x is going to be 3 and y will be what? -1. So there's a point 3, -1. Let's say this is -1. This is 1. This is 1, 2, 3, like that. So there's a point 3, -1 as part of your graph. 3, -1. From the reflection of this point in the line, y is equal to what? X. So there's a reflection there. All right, we do understand, guys, the type of the graph that we're talking about, the log with the base of 1 over 3, it's a decreasing function, but even from the points, we can tell that the graph is going to be like this. Remember, everything reverses. If before our x-axis was our asymptote, it means this time the y-axis is going to be our asymptote. The graph cannot pass through the y-axis. Everything reverses. So even the concept there reverses, guys. So it's going to be like this. All right, something like this. All right, a decreasing function. So this is a reflection in the line y is equal to x. So that's the log. Remember the log? They just said what the inverse of f, all right? So let's just put this one as the inverse of f like that. Okay, so they can ask these questions. They can ask these questions, guys. All right. So meaning to say, in our case, for this, the asymptote now is limited, guys, to the y-axis. Remember, the y-axis, we are talking about the equation x is equal to 0. So we are saying, in our case, for this log function, which is our inverse, x is greater than x cannot be equal to 0. It's an asymptote. X cannot be equal to 0. It's an asymptote. For the first one, it was y is equal to 0. But since it's a graph of the inverse reflected in the line y is equal to x, everything changes or swaps. So when we said y is equal to 0 is your asymptote. So changes now. Y changes to x. So x is not equal to 0 is now our asymptote for the inverse. Just like that. So y is equal to x, guys. That is you just swap everything. Swap everything you swap for y is equal to x. All right. So meaning to say we can attempt this question where they are saying write down the equation of what? The asymptotes. The asymptote of what? The inverse of x that we had, but it's what? X plus of x plus 2. Remember, this is the inverse of our f, which is the log. This one that we have here. Sorry for that. This one that we have here. This is our inverse, which is the logarithm of what? Of x in the base of a third. And we are saying when it is like this, it is limited to the x. All right, it is limited. I mean, the asymptote. We are talking about what? The equation of the asymptote is limited to the x is not x is equal to 0. That to say x cannot be at that value. So as our asymptote, we are saying x is equal to 0. X is equal to 0. That's our asymptote. Guys, when I'm saying x cannot be equal, I'm limiting to say x cannot be this value. But when the question is now mentioning to say asymptote, we are saying x is equal to. X cannot be equal to 0. We are talking about the limitation in terms of the x value. It cannot be that. But if the question now is specific to say asymptote, asymptote, remember that is the condition where where the graph cannot pass. It cannot pass x is equal to 0. So, all right. But in our case, we are comparing to the x. So now they gave us as what? X plus 2. X plus what? 2. All right. This is question 3.5. So they gave us as the inverse of x plus 2. So meaning to say we must determine that in place of x, it was just supposed to be like this, the logarithm. In place of x, you substitute x plus 2. All right, in the base of a third. But that was not even necessary because we can trace to see what happened. When we say it is log x, asymptote, x cannot be equal to, we are limited to say x cannot be equal to 0. So our asymptote is x is equal to 0. What about when it is log x plus 2? What simply happened, guys, is it's a transformation. It has been transformed from 0 there, from 0. But x plus 2 means what? Remember our transformation of f of x plus a. A units to the left. We moved to the left. So meaning to say, in our case, if we say x plus 2, it means we are moving to the left from the 0, from x is equal to 0 there. We move to the left. So the asymptote was now at x is equal to minus 1. To the left again, x is equal to minus 2, and so on and so on. It is moving to the left. So in our case, x is simply equal to minus 2 as our asymptote. We moved to the left. So x will be equal to minus 2 as asymptote. Because we are saying when we have got something like this, from this graph, x cannot be equal to minus 2 as part of your domain or the x values. X cannot be equal to minus 2. So therefore, x is equal to minus 2 is what? Our asymptote. Just like that. Reflection. I mean, not a reflection, but the shift, I mean, horizontally along the axis. We can shift the graph horizontally. We can shift the graph along the axis. What is it that, how is it that the graph is going to be what? Shifted or transformed? How was it transformed? 2 units to the left. Even the asymptotes does the same also. It moves to the left 2 units. So it will end up at what? At x is equal to minus 2. So the part of transformation, yeah, it's another thing, guys, that you need to work on question papers, revisions. But I think I explained that one. So just go through question papers where we have got this transformation of graphs and so on. So that was it for 2 marks and everything on question number 3, 9 marks. They can give us these typical questions. We just need to be very careful how we attempt them. Supposed to be very, very careful. On question number 4, so there we were given hx as y plus 2. So that is our hx is given as y plus 2 into x minus 3. And that is equal to negative 2. And this is a hyperbola. Remember the concept of a hyperbola, y is equal to a over x plus p plus q, or you can use x minus p depending with your textbook. This is what you're given, and they want us to write down the equation of their asymptotes, this and that. So for us to properly see what we are given, yes, we can deal with it as it is, or simply work it out, make y the subject so that it will be in that format. All right, let us just try to make y the subject of the formula here. Make y the subject. So meaning to say, we were simply gonna divide by this bracket of what? X minus 3 both sides, and that was gonna give us what? Y plus 2 is equal to minus 2 over what? Over x minus 3. We need y as the subject. What is affecting is this positive 2, so we can simply get rid of that by subtracting it both sides of our equation. So that was going to cancel, and therefore y is equal to what? Minus 2 over x minus 3 minus 2. This is the function of what? Of our hx as we are given. So that's our hx. All right, anyways, with this, guys, it'll be easier for you to even answer all of these questions. It's just rewrite, guys. But if you understand, still you can just use the one that you're given there. So 4.1, they wanted us to determine the equations of what? The asymptotes of h. So we have got the x asymptote first from the x minus 3. All right, so in that case, that's 4.1. From x minus 3, we're going to obtain our x as what? As positive 3 to the other side. Then remember, the y value, guys, it just remains as it is. You take the value of q as it is from this presentation. Your asymptote is going to be y is equal to q. 4.2, calculate the x and y intercepts. X and y intercepts. All right, so with this it will be easier, or you can even use that one, the original one, when x is equal to 0, when y is equal to 0. Still you can obtain your values, or you can work out from this part that we have here. So that's 4.2 for the x-intercept. We do understand y is supposed to be equal to 0. So that's y must be 0. So that's 0 is equal to minus 2 over x minus 3 minus 2. Then we can solve for what? For x. All right, minus 2. We can get rid of that one. Simply add that one both sides of our equation. That would be 0 plus 2, which is 2, which is equal to minus 2 over what? X minus 3. There is a fraction. This is same as over 1. So you can get rid of the fraction by what? Cross multiplying. The 2 multiplies everything here. So this is going to be 2 into x minus 3. 1 multiplies minus 2. So that's 1 times negative 2. All right. So anyways, if we're to expand these brackets, 2 distribute it, 2 times x, 2x times negative 3, that's negative 6. 1 times negative 2, that's negative 2. Add the 6 to get rid of that. So that's 2x is equal to what? Minus 2 plus 6, which is 4. And if we were to divide by 2, our x was going to be what? Our x was going to be equal to 2. So thus, we have got the x-intercept. For the condition that we are given, the x value is what? Is 2. And we do understand y is equal to 0 for the what? For the x-intercept as a point xy. Just like that. So with the same equation, guys, you can even determine your y-intercept by substituting into that. All right, so that is y-intercept for the condition that x is equal to what? To 0. So substitute x, which is what? Which is 0 there. So y is equal to minus 2 over what? In place of x, we're going to put a 0 there. So that's 0 minus 3. All right, 0 minus 3 minus what? Minus 2. All right, let us solve for this equation. We're going to solve for y, which is just simplifying, guys. You can just use your calculator as it is. Minus 2 over what? That's 0 minus 3. Then subtract 2 from that. You are going to get minus 4 over 3. All right, so that's minus 4 over 3, meaning to say our y-intercept at the end, where x is what? Where x is 0, y is what? Minus 4 over 3. So this is what you just needed. All right, minus 4 over 3 is same as what? Is a decimal. That's minus 1,333 and so on. Minus 1,333 and so on. All right, no problem. From that part, 4.3, they want you to clearly sketch the graph of h, showing the asymptotes and x-intercepts with what exists. So in our case, we have got these the x-intercepts. First, the asymptotes. Here, the asymptotes, as we had this this first part, we have got our asymptotes. So we can consider also our a, the part of a there is negative 2 from y is equal to a over x minus p plus q, or it can be plus there. Our a as what? Our a is a negative. That tells us that if we are given a negative from our asymptotes, we are going to have another piece, one piece from this side, another on this side, in the second and fourth quadrant. If it was a positive, it was going to be first and third, all right? Or, I mean, like from your asymptotes. So let's start with the asymptotes. It will be easier for us to tell how our graph is going to be like. So we're given that, we said x is 3 and y is minus 2. Those are our asymptotes. X is what? X is 3. That's 3 here on x, and that's an asymptote that we have there. So at x is equal to 3, we have an asymptote there. our graph cannot pass that. All right, it cannot pass that point that we are having. I mean, cannot pass this line. X is equal to 3. We also have y is equal to minus 2. So y is equal to minus 2 is an asymptote. Y is equal to minus 2. Our graph is also limited to this line of what? Y is equal to minus 2. So like I said, on our shape, because of this asymptote, we're going to have this side and this side. So this is part of our asymptotes. So meaning to say another part is going to be this side, another part is going to be this side. That is how it was going to look like. So on this side of our graph, as we can see, there are points to be indicated. There we have got space there for the x-intercept and also for the y-intercept. But for this side, guys, there's no x-intercept because it cannot pass y is equal to minus 2. It cannot pass x is equal to 3. So we are just going to have a piece on this side of our graph. But here we must indicate where it is going to cross the x-axis and the y-axis. That's where we need those intercepts. All right, the x-intercept 2, 0. That is x is 2. Direct here in the x-axis, x is what? X is 2. We mark the point. The y-intercept in the y-axis is what? Minus 4 over 3 or minus 1, 333 and so on. So minus 1, 33 maybe somewhere here because this is minus 1, 5. So minus 1, 33 maybe somewhere there. That is where we have got our minus 1, 333. All right. So thus we're going to have another piece. As I said, one piece is going to be this side and another one this one. So this is what we were going to have. All right, sorry, to the minus 1, 33. Just try, guys, to have something small right here, guys. You see this thing of not seeing where you are writing. It causes. Okay, let's just try. And this is too much spaced. It's too much spaced also. But something like this. All right, something like that. Okay, and this piece that we had here from our asymptotes. If it was a positive, there was gonna be something this side, something this side. All right, so we must be very careful. So that is our graph for what? The graph of h that we're given. So we're just gonna write h here, or you can write h on the other piece. That is up to you. So you start with asymptotes. Asymptotes first. You are limited on your asymptotes. All right. Then on the other part of our question, we are now given if hx is given, sorry, if gx is given as what? As h of x plus 2, write down the equation of the vertical asymptote of what? Of g. So gx here is simply means in place of what? In place of x from our hx plus 2, substitute this x plus 2. In place of x, put what? X plus 2. Then analyze what you have. Remember, this is our hx. Our hx here. So in place of x there, we are going to put x plus 2. That is what we are simply going to have. So meaning to say, at the end, our gx was going to be equal to minus 2 over what? In place of x, that is x plus 2. So that is going to be x plus 2. But remember, there is what? A minus 3 originally given. So that is it. Then we subtract these 2 that we have on our original equation like this. Okay, so this is it. This is our gx. So meaning to say our gx at the end of the day was going to be minus 2 over what? Simplifying, collecting the like terms, that's 2 minus 3, which was going to give us negative 1. So we have got x minus 1 at the end, minus 2. And our question is, from that gx, determine the equation of the vertical. They just want vertical asymptote. vertical asymptote. Remember, vertical lines, these are the vertical lines. The lines of x is equal to what? X is equal to a. So in our case, we are dealing with what? With x. So therefore, x minus 1 being equal to 0, x is equal to what? To 1. That is our vertical what? Asymptote. Answer the question. The question here is not to determine all. This y is equal to minus 2, guys. It's a horizontal line, horizontal asymptote. Y is equal. But they wanted what? Vertical, meaning to say x is equal to what? X is equal to 1. So this is how we can simply work out these questions, all right? All right, so that is it on this one. And this one, that was it. If we are to consider another part of our question, we are given this time that on 4.5, if the graph of h is symmetrical, all right, the graph of h is symmetrical about the line y is equal to what? Y is equal to minus x plus c. That is the axis of what? The axis of symmetry with a negative gradient, this one, with a negative gradient. Determine the value of c, all right? So the question was just direct there. To determine the value of c, guys, already we've got the format. We just need what? Where this axis of symmetry passes. Remember, the axis of symmetry passes through the what? The intersection of the asymptotes, where we have got these asymptotes. X is equal to 3 and what? Y is equal to minus 2. 3 minus 2. Whatever that you're going to have with a negative gradient is going to pass through what? The point of intersection from what? Your asymptotes. For a positive gradient going that way, still is going to pass through the same point. So you use what? The point 3 minus 2 from your what? From your asymptotes. X is what? X is 3. Y is minus 2. That was part of what? Our asymptotes. It passes through that part. It passes through that point, I mean. So if it passes through the intersection, which is a point now, you have got the x value and the y value. So use that, substitute our y value, minus 2 is equal to x. So that's minus 3 plus c. So we can solve for c. Add 3 here. So that was going to cancel. C is equal to what? Positive 1. So that's it. Our c is equal to what? Positive 1, just like that. So you see, guys, just basic questions. They will ask this. 11 marks. It's a lot in exam. This is a lot in exam. Remember, March test, guys, we are fighting for our marks here. We want better marks for our preparation. So you must try by all means that everything that you do, guys, is proper. All right, on question number 5, we had another graph, which is the graph of what? There are two graphs, actually, f of x, and which is a straight line here. So we're given minus x, minus 2, and the gx, which is a parabola or a quadratic graph or a quadratic function. So we have got a linear, a straight line, and we have a quadratic here, or what? A parabola. They are given the graphs. These two graphs, they do intersect, all right? They intersect at what? A and Q. So A, it is the x-intercept, yes, but also it is the point of intersection for the two graphs. And also we have got what? Q. So those are the two graphs that we are given. Let's try to just present them separately. Here, this is our F, all right? And this is our G, the parabola. Y intercept to the turning point, point of intersection, x-intercept going up like that, all right? So this is what we had. Okay, then the questions were just direct. Question 5.1, it was just a direct question. The length of AB. Determine the length of AB for 4 marks. To have the length between 2 points, and in our case, AB, guys, A to B. This is a horizontal line, horizontal for the X values. We simply need the X at A and the X that is at B. Since B is more positive, is on the positive side, that's the bigger value. So meaning to say the length of AB can be what? Can be determined as the X value at B minus the X value at what? At A. The one that is more positive to the one that is what? On the negative. Or we simply say the right minus left. The one that is on the right minus the one that is on the left. That is the condition. More positive. If it is for the Y values, you do the same thing. The one that is on top, Y2 minus Y1. The difference between for a vertical line. Horizontal X values. So what is the X value at A and B? We do not have. But A and B, they represent what? They represent X intercepts. A and B, these are X intercepts of what? Of the graph of G. So if it is like that, let us determine them from what? Our Gx. X-intercept at that moment, y is supposed to be equal to 0. So meaning to say we're going to equate our Gx to 0. That is x squared as it is there. X squared minus 6x minus 16 must be equal to 0. Then solve for x, since we are referring to the x-intercept. So for what? For x. That's factorization can work here. Minus 16, since this is 1, simply have two brackets. All right, using factorization method, or you can use the quadratic formula. It's up to you. So you're going to have x and x since the coefficient is 1. Then let's consider the products or factors of what? Negative 16. Factors or products of this negative 16, but they must add up to negative 6. Right? What are the products, guys? Two numbers. You multiply two numbers, you get negative 16. Negative 16. There are so many numbers, so many numbers. Negative 16 and 1, negative 8 and 2. Also, here it's going to be 16 and negative 1. Here it's going to be 8 and negative 2, 4 and 4, but it's negative 1. All right, so where we add and get a negative 6, it was going to be here. If we add these two, we're going to get a negative 6. All these guys, add them on your calculator. They're not going to give you. So this is what we want. Minus 8 and what? A positive 2. So that's it. We can have our x values by solving from the zero product. The product of two terms giving us a 0. So that's x is equal to minus 8. To the other side will be what? Positive 8. Or x is equal to 2 to the other side will be what? A negative 2. So according to our diagram, which one is going to be positive, which one is going to be negative? As we can see, A is on the left side of the origin. This is our origin. So A on the left side is going to be negative. So the x at A is what? Negative 2. That's negative 2 there. The x at B is the one that is going to be what? Positive 8. So this is it. With these, we can determine our length. So we are saying this is the x value at B. This is the one at what? At A. And we said AB is simply the difference, the x at B minus that one at what? At A. It's just like that. Which is 8 minus the x value at A, negative 2. So at the end, that was going to be positive. Or just use your calculator, guys. You're going to get 10 units. So we're determining the length. Length in what? In units. Just like that. They said length. Without x values, there's no way. We must have those x values that we are given. It is a horizontal distance. So by solving our equation, since those are x-intercepts, an equation can be formed from understanding that one. All right. Anyways, let us check another part of our question, which is 5.2. Determine the coordinates of what? Q. 4 marks. Q is here. That's part of your intersections, right? When we consider A and B, those are the points of what? Intersection. So already A is there. We calculated it when we calculated the x-intercepts. It's an x-intercept, and also it is there on the intersection of the two graphs. So that one is not going to limit us to determine or to calculate again, because there is no way we can have this point at Q, even the x value. There's nothing that we can do. So the only way, let us just solve. All right, so 5.2, we need the coordinates of what? Q, which is the point of intersection. Point of what? Intersection. At the point of intersection, the two graphs are equal, the graph of G and the graph of what? The graph of X. So, I mean, of F. So, Gx and f of x will be equal, where we've got our Gx, x squared minus 6x minus 16 must be equal to f of x minus 2. All right, whatever way you can say this is equal to this or this is equal to this. All right, anyway, this is a quadratic equation, guys, the highest power being 0. So remember the format of a quadratic equation: ax plus bx plus c is equal to what? Equal to 0. One of the sides must be equal to 0. So we're going to take the minus x to the other side, becomes a positive minus 6x plus x. The minus 2 to the other side becomes a positive minus 16 plus 2, right? So we're going to have x squared minus 6 plus 1 is negative 5x minus 16 plus 2, that's minus 14. All right, so this is equal to 0. We can use our factorization, quadratic formula, whatever that you understand. But here, guys, because this is 1 and this is a smaller value, guys, that you can just use. Avoid when it is having bigger values, but 14, this is a smaller value. So factorization, I think, is going to be best here. So this is x, and as we consider the constant, negative what? Negative 14. What are the products? And these products should add up or give us what? Negative 5. Products of what? Negative 14, or factors of negative 14. There are so many. Negative 14 and 1, 14 and negative 1, negative 7 and 2, 7 and negative 2. So many. But which one of these, when we add, we must get a negative 5. This is negative 7 plus 2, which is going to give us a negative 5. So this is it, negative 7 plus 2. So let's solve for x. Minus 7 to the other side going to be positive, or x is going to be what? A negative 2. But remember, we are talking about the point Q. There are two possible values. So which one represents Q? Remember, A and Q, those are the ones representing our points of intersection. And at A, we already have the x value. Remember, we calculated, and it is what? Minus 2. So at Q here, x cannot be minus 2. All right, so x cannot be minus 2. This is the value of x at what? At A. So at Q, this will be our x value. This is the one that we want, which is what? 7. So this is the x value at what? At Q. So the question was to determine the coordinates. So what is the y value now? If x is equal to 7 at Q, what is the y value? Remember I said these two graphs, they are equal. So you can substitute now in any one of the two graphs, any one of your choice, to find the y value. So I'm just going to use the easier one, guys. Minus x minus 2. So y is equal to, when x is what? 7. All right, so that was going to be negative 9. So as a point which represents Q, our x is what? 7, and the y value is what? Negative 9. So this is exactly what we have. All right, does it make sense? 7, negative 9. All right, it can make sense, because All right, can make sense because here x is 8 at B. So at Q it's what? It's 7. It actually makes sense. So the point is 7 what? -9 like that. All right, so that was it. To determine the point Q, we can use the point of what? Intersection concept. The two graphs are equal, so you equate them. Then solve for x. By solving for x, substitute that x in any one of the two equations, then you have got what? The y value from there. All right, let's consider another part of our question, which is now on 5.3. They are saying, show that, meaning to say you already have the answer there. Show that the coordinates of the turning point are 3 minus 25. The turning point. Which of the two graphs has the turning point, guys? It is the quadratic, the parabola G. The turning point, which is actually a minimum turning point. They said, show. Simply calculate it from the way that you understand, all right? So that's our 5.3, working with the turning point. There are so many ways, but as we are preparing for the March exam, March test, we understand that you will be working with the sections according to term 1, and by term 1, according to your ATP, you will be having what? Functions. You will be having trig, which is your trigonometry, and number patterns. No derivatives. So meaning to say that idea of a derivative, yes, if you understand it is fine, because some of you guys are reading in advance. So for those who will be working with those, you can use the first derivative is equal to 0 at the turning point. All right, but this is for a March exam, so basically you'll be just working with what? The formula that you are used to say at the turning point, x is equal to minus b over 2a from our f of x, which will be given as ax squared plus bx plus c. X is equal to minus b over 2a. You can use this formula, or you can also use the formula that I stated before, that the x at the turning point, it is equal to the average value. This is the between these 2 points. It is in between axis of symmetry. So it is in between. Remember, this is the axis of symmetry. For the x values, the x intercepts. So you simply have to add the x at A plus the x at B over what? Over 2. So any one of these, or you can use the derivative concept if you understand it, all right? So, all right, so that's it. That is it. If we are to take minus b over 2a from our f of x, this is 1. So that's a, b, c. So that is our x was going to be minus, what is our b? Minus 6 over 2 times a. Our a is what? Is 1. So at the end, x was going to be negative, or just use a calculator here, negative of negative 6 over what? Over 2 times 1. That is, okay, what is it that I missed here? Or negative 1. We put a negative 1 there, okay? What? Oh, I did not close the bracket. It's all about the bracket here, I see. Okay, no problem. So that was going to give us what? 3. So that is the x value at the turning point. Is the same that you're going to use from the that you're going to obtain from the derivative concept. It is the same here if you use this formula to say x at the turning point, since it is at the axis of symmetry, it is the average from the x intercepts a and b. So that x will be equal to the x at a minus 2 plus the x at b, which is what? Which is 8. Everything over 2. So that was going to give us what? A 3 again. So it is up to you which one is it that you want to work with. But with this, we can determine the y value now at the turning point. Remember, we need a point. So y is equal to 1x squared, which is x squared, 3 squared, minus 6x, 6 times our x, which is 3, minus 16. We substitute into the gx as it is to obtain the y value from there. So that was going to give us the y value, all right, which is 3 squared minus 6 times 3 minus 16, and that was going to give us what? Negative 25. So is it the turning point that we are given before, to say our turning point x is 3 and the y value is what? Negative 25. Is it the one? Because they say the show. Yes, it is the one. So that is exactly what you're being asked to show. So we have got our turning point in that case, all right? So just like that, guys, or you can use, so the derivative there, you can use it if you understand it, all right, to determine the x value at the turning point. All right, moving on to another question, which is 5.4. For which values of x is f of x greater than gx bigger than f of x? For which values are we considering? 5.4. That f of x must be greater than gx. We compared, but if the graphs are drawn, guys, you've got your graphs, guys, they are already drawn. Just consider where f of x is above gx, because it's greater than. So it's on top of what? Of gx. If it was less than, it means below gx. So we need where f is what? Above. It is found on top of gx. All right, so let's consider our f. From here, as we can see, guys, the g is the one that is on top, because g is like this. G is one on top. F of x is below. It's below. It's below. It's up to a at what? At negative 2. At a there, the moment we continue with our f of x, we can see that f of x is now above. It's on top. Look, gx, guys, is found below f. F is the one that is on top here, up to point q. F of x is what? Is on top of this gx. It is the one that is on top. Gx is below them. From there, from the point q, if we consider our f of x, it is now below. Look where gx is. Gx is the one that is now on top. But f of x is what? Below. So the region where it is above, where it is on top, it is only here on this region. This is the only region from A to what? To Q. From A to Q. So meaning to say our x values must be greater than, we need the x at what? X at A minus 2, but less than the x at Q. Remember, at Q, our turning point, 7 minus 9. The x value there is what? Is 7. Just like that. By looking into the graph, this one is found on top, it's bigger than. So the same question could have been asked as, which region is it that gx, because here gx is being pointed by f of x. So gx is less than f of x. They could have asked this same question that we are seeing here as this. This is where gx is less than what? F of x. Gx is below f of x. Gx is below f of x. This is the region from minus 2 up to 7. They could have asked that question in the same, in a different manner, but referring to the same region, the same answer. So you see now the issue of revision. Same question can be asked in different manner, but still one and the same. Determine for which value of k will this whole part that you're given there have what? 2 equal roots. two equal roots. They are equal. Remember from our grade 11 mathematics, we talked about these numbers, comparing our numbers using the discriminant. We are given this. For us to have two equal roots, we understand that our discriminant must be exactly equal to 0. We are referring to b squared minus 4ac must be exactly equal to 0. What is our b, our a, and c? Remember from the quadratic equation, ax squared plus bx plus c is equal to 0. A as the coefficient of what? Of x squared. What is the coefficient of x squared? The number that we have there is what? Is 1. If it is not given, there is a 1. B being the coefficient of x. What is the coefficient of x in our case? This is what? Negative what? Negative 6. And c as the constant. So our constant is going to be k plus 4. The whole of this part is our constant, k plus 4. So that is representing our c. So we have our a, our b, and our c. Substitute that. B squared, b, our b is what? Negative 6. Minus 4 times a, our a is 1, times c, which is an expression of what? An expression of x plus 4. This must be exactly equal to 0 for us to have two equal roots, two equal real roots. All right, so minus 6 squared, negative squared is going to be positive. That's 36. Minus 4 times 1, that is going to give us minus 4 into k plus what? K plus 4. So that's equal to 0 there. So solving here, guys, it's in your hands. You can take them 36, the other side. You divide by minus 4. You can expand the brackets by this negative 4 throughout. It's in your hands, all right? So I'm just going to expand. Negative 4 times k, negative 4k. Negative 4 times 4, negative 16. That's equal to 0. 36 minus 16 is going to give us 20. So that's minus 4k plus what? Plus 20. Equal to 0. So you can get rid of that 20 by subtracting it both sides of our equation. So meaning to say negative 4k is equal to what? 0 minus 20 minus 20. So divide by negative 4 by negative 4. Our k was going to be what? 5. So that's a positive 5 that you're going to have at the end. So this is the value of k that we are going to have. That's why you see even on your question, they never say value or values, because they know that you're going to just have a single value of x. It's not an inequality that you're solving. You're solving an equation where there is an equal sign, an equation direct. So for that equation, you are going to obtain an exact value, a single value representing what? Your k. That is it. Equal roots. They are real and equal. Another part of our question, that was question 6 as part of our trigonometry. 6.1, if the sine of 56 degrees is q, determine the value of the following in terms of q without the use of a calculator. All right, so the sine of 56, if you were to represent it, that was going to be an acute angle, right? So you're going to have 56 degrees, where the sine is what? From our SOHCAHTOA concept. From our SOHCAHTOA concept, it's opposite over adjacent. So the sine of 56 degrees is equal to q over 1, so that we can see our opposite over hypotenuse. Where am I getting adjacent? Did I just say adjacent? Opposite over hypotenuse. All right? So meaning to say, we can use that on our diagram because it's a right angle triangle, remember? So that's our opposite according to 56. This is our opposite. So that's our q. Hypotenuse facing 90 degrees, that's our 1. So you're supposed to calculate the adjacent side, which represents the x values. So remember your Pythagoras theorem, guys, in order for you to calculate for the value of x, all right? You need to understand your Pythagoras theorem. That is r hypotenuse, r squared is equal to x squared plus y squared. So r squared, that is what? That is 1. 1 squared is equal to x squared plus the y represented by what? By q. Then take this to the other side. 1 minus q squared is equal to x squared. Introduce the square root, the square root. So that's our x is the square root of 1 minus q squared. The x value is going to be the square root of 1 minus q squared. All right, so this is it. Also try to find everything. Just solve everything, guys. Even the angle, you might need this third angle in a right angle to triangle. You know that these two angles, they add up to what? 90 degrees. They are complementary, the remaining ones. So 90 minus 56 is going to give us 34 degrees. Also, determine that. All right, so this is it. Anyways, with our diagram, we can answer our questions, and that's in this case. All right, we have to answer every part. So looking into 6.11, it is sign of what? Negative 56. So to answer these questions, guys, we must remember everything. Remember, we did almost everything according to your syllabus. Back to your grade 11 mathematics, reduction, because we are dealing with a negative angle there. The sign of what? Negative 56 degrees. So as it is a negative angle, remember negative angles, this is negative theta. In this quadrant, we're going to have theta minus 180 minus theta minus 180, theta minus 360 as what? Negative angles. So minus theta is in the fourth quadrant. And using our cast concept, we can see that this is the quadrant for cos. So sine there is a negative. Sine of minus theta is what? Negative sine of theta. So the same thing, this is negative sine of what? 56 degrees. Are we having that? 56. Yes, it's the one that we are already given. We have this. We have it, guys. So simply substitute with its equivalent, which is what? Which is q. So that's minus q. Just like that. So we've got sine minus 56. Let's have another question in case we are going to need this one. That's negative q. 6.12. On 6.12, that is the tan of 124 degrees, which is also to be reduced. But this is a positive angle. As we can see, there is no negative here, guys. It's a positive angle. For positive angles, remember theta, 180 minus theta in the second, 180 plus theta in the third, and 360 degrees minus theta in the fourth quadrant. So 124 lies in the second quadrant from 0 degrees, 90, 180, between 90 and 180. So this is the quadrant of 180 minus theta. So we must have this written as the tan of 180 degrees minus what? To get 124. 180 minus 124 is what? 180 minus 124, that's 56 degrees. So as you can see, guys, it can be written in that format. You try, because the double angle is not going to work on, if we divide it by 2, 124, divide by what? By 2. That's 62. We do not have 62. So there is no possibility of us having tan of 2 times 56 or 2 times the other angle 34 that we saw. That's the double angle, not going to test it. We're going to work with our reduction. So from our reduction, the tan of 180 degrees minus theta in the second quadrant, which is the quadrant for what? For sine. It is a negative. Sine is positive, remember. So tan gets a negative there. It is negative tan of theta. Our theta is 56. We are taking our theta as our acute angle. This is our theta. So it's just like tan 180 degrees minus theta, which was going to give us negative tan of theta. So that's negative tan of what? 56 degrees. We have it. We do not have, but we can determine from the triangle, because this one is from our trig ratios, tan opposite over adjacent. Remember from that SOHCAHTOA concept. So you are going to use that concept. All right, opposite over the adjacent. According to 56 degrees, our opposite, that's q, adjacent, this is square root of 1 minus q squared. So that's going to be negative of what? Opposite over adjacent. So that's our opposite q over what? The adjacent, which is the square root of what? The square root of 1 minus q squared. So this is it. That is how these questions can be given, as it's just a matter of playing around with the information that you're given. So simplifying or evaluating this, we're going to obtain negative just multiplies here. So it's going to be negative q over what? The square root of 1 minus q squared. Just like that. So questions can be given in that manner. Figure out how to play around with that information, this and that. So this is it. 6.3, 6.13, it's a cos of 4 degrees, cos of 4. All right, this is complicated because we do not have any angle that is nearer that 4 degrees. 4. There is 56, 34. And the difference between these two angles cannot even give us a 4. 56 minus what? 34. It is way too far. All right, so we cannot also use the double angle, because if we divide this 4 divided by 2 is going to be 2. So there is no cos 2 times 2, because we do not have 2 degrees. Double angle is out. And these two, they don't have anything in relationship with what? To 4. So when it is like that, think of other identities. But before, you can consider cofunctions, because we know that cofunctions, they work, the cofunctions, they work with 90 degrees minus x, 90 degrees, whatever x that will be given there. So from these two, is there any part that we're going to get 4 degrees if we say 90 minus 56? Not. 90 minus 34? Not. There's nothing there. So cofunctions are out. What are we to use now? We are stuck. Since we are dealing with angles here, let's go back to our special angles. Let's go to the special angles. Special angles can also be of assistance because they are known angles. 30 degrees, 45 degrees, 60 degrees, including the 0 and 90, but those ones, they're not going to work for now. So we are saying from special angles together with these ones, they are now special angles because we have their values. So together with the angles on our diagram, 56 degrees and 34 degrees. Is there any part of the where we can combine these and obtain a 4? Because whatever that you're going to have from 56, whether it's tan, whether it's cos, whether it's sine, you are going to obtain its value. Whether it's 34, 56, 34, whatever that you have on the diagram is there. So they become part of your angles now. So you consider them together with the special angles and see. We are still testing, guys. Maybe it's not going to work. So is there any of the two angles here from special angles and these ones that we are given where we can combine and obtain a 4 by adding or subtracting. All right, there's something relationship here. There is a 6 and a 0 there. It's gonna give us a negative, which is not a 4. There's a 6 and a 0 there. So these ones 60 and what? 56. 60 minus what? 56. That's a 4. So we have what we want. Guys, all here with testing, it's not like you'll be knowing your answer in exam. Don't lie to yourself unless you know. To say, all right, this one, there's a 60 and a 56 direct. So you test where possible. So we saw that these can be obtained from these two angles, 60 and what? 60 and 56 degrees. 60 from our special angles, 56 from what we are already having on our diagram. So as we have got these two angles now, it means we are forced to expand them now. Remember our double angle, compound angle identities, they are used to expand size. So here for our compound angle, cos alpha minus what? Minus beta. From our formula sheet, remember we talked about these guys. Cos alpha minus beta is going to be what? Cos plus sine sine. So it's cos sine sine. So that is, all right, so this is equal to cos 60, cos 56. All right, plus the sign changes to plus. It's going to be sine sine. The sine of 60, sine of 56. All right, so that's sine there. All right, so you see these boards, guys, sometimes they just tend to misbehave as you are working with them. I don't know, they just want maybe for you to be holding something for them to work. Technology, guys, I don't even know. But we just try for you guys to have the information that you want, or we just hope as time goes on with technology, they will also advance them so that they do not shrink or do these things when you are working. Sometimes when you need to explain something important, you say now it stuck. Guys, what's that? Anyways, let's see here. The cos of 60 degrees, sine of 60, these two will be taken from our special angles. But I said, guys, there's nothing special about these because we know their values, isn't it? We know the cos of 60 degrees, that it is 1 over 2. The sine of 60 degrees, square root of 3 over 2. But if you do not know, then use your calculator straightforward to find those values. Even if they said do not without using a calculator for special angles, those are values that can be obtained even by your head. All right, or you can simply use your diagram for an angle of what? 60 degrees. We do understand this is 30, this is 60, sorry, 60, 30. So you're going to be 1, 2, square root of 3. So cos 60 can be obtained adjacent over hypotenuse, 1 over 2, like I was saying before. So this is 1 over 2 times the cos of 56 degrees from the diagram now in terms of Q. 56, cos of 56, what is the ratio of a cos? All right, cos is what? Adjacent over hypotenuse, adjacent over hypotenuse. So that was going to be square root of 1 minus q squared. Square root of 1 minus q squared over 1, the hypotenuse, all right? Plus the sine of 60 degrees from our diagram, sine from our SOHCAHTOA, opposite over hypotenuse, square root of 3 over what? Square root of 3 over 2. The sine of 56 from our diagram, here we are given, that was already given as what? As a q. So it's already given as what? As a q. So this is it. We are done with this part, guys. Yes, you can simplify, but here, guys, we are done. You can even leave it as it is. 1 times square root of 1 minus q squared over 2 times 1, which is 2, plus this one is same as over 1, so it's square root of 3 times what? Times q over 2. The square root on its own. That's it. You're done. Or you can even combine, if you want, you can even combine it to a single fraction since the denominators are the same. So that's 2. gonna have to combine the numerators. Just have to combine the numerators. So that is the square root of 1 minus q squared plus this numerator as it is square root of 3 times what? Times q. Just like that. All right. You can have it as a single fraction if you want. If you want, you can have it that way. It will be in your hands. All right. So that was our 6.13. We had to also include the special angles. All right. 6.2. Use the above identity. All right. The above, which one? Or they just say use this identity. There's no above. It's here. All right. To prove that this here is the same. All right. So, all right, I want to use this identity. As they said, we must use this one, cos of this. Okay, so let's try to use that to apply it. How can we apply it while we are given a sign? Because here we are given a sign, isn't it? We are not given a cos. This is a sign. All right, anyways, 6.2, taking the left-hand side of my equation, that is equal to the sign of what? A minus B. I'm supposed to prove that it must give, it's supposed to give us this thing. All right. But they said use this one for cos. But we have a sign. We must change that sign to look as a, or to look like a cos. Remember, a sign can be changed. Sine of x from our cofunction is cos of 90 degrees minus x. So sine of an angle is cos 90 degrees minus that angle. So meaning to say we can have it as a cos of 90 degrees minus our angle. What is our angle in this case? Our angle is the whole of this part. Sine of x. Sine of what? Sine of a minus b. So this is a minus b as it is. That is representing our, this is representing our x. So what we need is to have it in that format of cos a minus b, a minus b, a minus b. So here we can use as it is now, but it is going to affect us later on because you'll be having to expand it, and there'll be cos of this, and there'll be cos of this one. So do you see that when you're at cos of this value, you must expand, but sine of that one now, you cannot expand. You will be back now to the sine of a minus b, of which you can just, it's going to complicate, guys. All right. So the best way for you not to have complications, because it's maths, guys. You know, maths, you can play around the way that you want. So as we need properly to see a minus b with no complications, so let us just expand here and see what we're going to have. 90 negative times a, that's going to be negative a. Negative times negative b is going to be what? Positive b. Okay. So if we use this one, or if we check out what we have. All right, guys, you see these full papers now, they affect us now. Why are they affecting today like this? Anyways, let's see. I just hope I'm going to finish up. So if we look here properly, you are going to see that we have the a minus b concept can be obtained if we combine 90 and what? And beta. So if we take these two together, 90 and beta together, it will represent our a like a. Then minus b is going to be represented with what? That minus a, that this part of a, which is negative b, which is negative what? A as it is here. Yes, 90 plus beta can work because we know those identities, I mean the cofunction where 90 plus beta is used. So yeah, it can work. It can work. It can work. It can work. So I'm going to take 90 and beta together, then separate like this with a. So like I said, guys, there are so many ways, but I think I have explained this way before. So I'm going to maintain that so that you can just maintain that, guys. All right. So it is the same as we are given. They said cos of a minus b is supposed to give us cos, sine is sine. All right. So this is it. This is our A and this is our B. So it was supposed to be cos of A, cos of B. Cos of A, what is our A? 90 degrees plus beta. Cos of what? Cos of B. What is our B? That is our A, according to here. The sign, it changes to what? A plus. Plus sine times sine, because they said use that one. So the sign changes. So it's now sine of what? 90 degrees plus beta. Where am I getting beta now? This is B. You see this thing of being used to that beta. All right. Sine of what? Sine of A. So this is B there. All right. So we have used that identity. They said we must use that cos A minus B identity. So this is the one that we used it here. So after using this identity, we can see that still our answers are not the same because they were supposed to be sine A cos B. Cos A sine B. So how can we simplify up to that? Cos 90 degrees plus x. It's a negative angle. It lies in the second quadrant. So when we are using our co-function, it will be negative sine of x. So meaning to say, this will be negative sine of what? Our x is what is beta. So that's negative sine of beta, cos of what? Cos of A. Sine of 90 plus beta, this one. Sine in the second quadrant, it's a positive. So meaning to say, cos is not affected. It will just remain as a positive. So that's cos of what? Of beta. I mean, cos of B. Where am I getting beta, guys? All right, cos of B, sine of what? Sine of A. So this is it. We just have to rewrite the way that we are given there, because we can see this is exactly what we have here, but only just rewriting sine A cos B. Our sine A cos B, this is the one that we are having here. Sine A cos what? Cos B. Exactly what we have there. We're just rewriting in that manner. Minus what? If we check, this is exactly what we have. Sine B cos A, like that. Cos A sine B. So this is it. Cos A sine B, as it is. Cos A sine B. Remember the negative, we have already used it here. So that's it. Cos A sine of what? Of B. So that is it. We have proved that truly sine of A minus B is equal to this. But we had to use the identity that they gave us. Without that, guys, you're working something else, because they say you must use this, apply it. So it's given in terms of a cos. So that is why we had to change it to be cos of A minus B, cos 90 minus x from the co-function concept. All right, so they can ask these questions. Simplify to a single trigonometric ratio of what? Of A for 5 marks on 6.3. All right, let's see. To a single trigonometric ratio of what? Of A. All right, so let's see here, just matter of playing around. I'm just gonna adjust it. That's equal to what? 6.3. Sine of 2A. All right, for the meantime, let's just leave it as it is. Sine of 2A. The cos of minus A, that's a negative angle. Remember, minus theta in the fourth quadrant, and that's the quadrant for cos. So cos is going to be positive there. All right, cos 180 plus 2A, it's that's a positive angle in the second quadrant. Remember, that's the quadrant of 180 plus theta. And that's the quadrant of a sine. So cos is a negative. So it's going to be, all right, there was a plus, which was part of our formula. So let's just have it so that we do not have confusion. So there was a plus as part of our question, but I'm saying if you reduce this cos of 180, hey, guys, where am I getting this? Yo, someone's mind is tired now. This is minus theta here. This is 180 plus theta. I think someone just said, what is explaining now? What is this guy explaining? this time. All right, so let's correct this. This is in the third quadrant, isn't it? 180 plus here in the third quadrant. So that's still a negative. It was just going to be by coincidence, but in terms of proper calculation, we're doing something wrong there. All right, anyways, by correcting this, it's negative what? Cos. This is the quadrant for tan, so cos there is a negative. So of what? Of 2a times the sine of a. Is there anything that you can do? Just leave it as it is. All right. So everything here is over what? Everything over the sine of a minus 90, which we can also consider in that format we are used, guys, when it is sine 90 degrees minus a, like that. We are used to that format. So what can we do to obtain that? We can factor out the negative. Remember the concept, when you factor out a negative like this, it's going to be minus a plus 90, which is 90 degrees minus a, if you factor out a negative. So it means we are referring to a sine of what? A negative value, where a negative angle in the fourth quadrant, it's cos, which is what? Positive. So sine is what? A negative. So it was going to be negative sine of what? 90 degrees minus a, like that. So you have to change it in a format that you understand so that you can use your core functions. All right. So simplifying the numerator, there's something common. Let me just rewrite it. There's something very, very common. So if you don't see it now, it's going to be a problem. Sine of 2a, remember, cos of a, plus and minus is going to give us what? A negative here. So we're going to get a negative cos of 2a sine of what? Sine of a. Everything over what? Negative. Remember, cos 90 minus a, I mean sine 90 minus x was taken from cos of what? From cos of x. So this is cos of what? Cos of a. All right, I'm worried about the numerator. If we check properly in the numerator, there's something common. Sine cos minus. Is it not the same that we just had here? Sine a minus b, it's sine a cos b minus cos a sine b. Are we seeing that these are the same, guys? These are the same. As long these two are exactly the same here, the angles. All right, need the angles here. Sine 2a. The other side is what? Cos 2a, same angle. Cos a sine a, same angle. Sine cos, cos sine. With a negative, it was taken from what? From cos, from sine a minus what? Sine a minus b, from what we just proved, or from what you're given from your formula sheet, alpha minus what? Alpha minus beta, if you are using that. So it was sine alpha minus beta that we are simply taking it from, or where we are taking it. So if it is sine alpha minus beta, guys, what is our alpha? This is our alpha, this is our beta, this is our alpha, this is our beta. As you can see, one and the same thing. So it was going to give us the sine of 2a minus beta, which is our beta is a. So it's sine 2a minus a. Everything over minus cos of what? Cos of a. So this is equal to a minus a, 2a minus a is going to give us 1a. So that's the sine of a over what? Negative cos of a. But they said as a single trig, sine over cos was taken from what? From a tan. So this is negative tan of what? Negative tan of a. As a single trig, as we are given there. That was going to be tan of what? Tan of a. So you see how they play around. This is what we had 6.3. Let us check another part of our question, which is 6.4. We were given that given this identity, all right, what happened here? This identity, prove the above identity. Prove it. So in my case, I'm going to take the most complicated, which is the left-hand side, where I've got a lot of things there. So taking out the left-hand side on 6.41, we had cos, all right, left-hand side is equal to cos of 2x plus cos squared of x plus 3 sine squared of x, everything over 2, everything over what? 2 minus 2 sine squared of x. So we are to prove, yes, but also check what you have on the right hand side is just a cos squared, 1 over cos squared, meaning to say our answer is just in terms of a cos. Our answer is just cos. So is it possible that we get rid of every sine and just have it as a cos? All right. So we're going to start with cos 2x. We need x, not 2x. So we must get rid of the cos 2x. Sine squared. All right. And this also sine squared. All right. So remember that cos 2x, that one is a double angle identity where there are 3 of them for cos. Cos 2 alpha can be cos squared alpha minus sine squared, can be 1 minus 2 sine squared, can be this. So we need where it is cos only. So we're going to take this one because our answer is in terms of cos only, guys. So don't use something that has a sine there. Yes, you can use it because maybe it's going to cancel because we also have a sine squared there. It will cancel, then you combine, but just take the one that has a cos already, all right? It is up to you. So I'm going to use the one with a cos, which is what? 2 cos squared alpha minus 1. So this was going to be 2 cos squared of x minus 1. We need x, not 2x. Plus cos squared. Since our answer is having cos x, guys, 1 over cos squared. So leave that cos squared, all right? Leave it as it is. Sine can be changed to a cos. Remember from our Pythagorean, this is 1 minus what? Cos squared of x. All right? Cos squared of x plus sine squared of x is equal to 1. So you can simply make cos the subject of the formula there. So this is the same thing that you are going to substitute in place of this sine squared as we had this one before as what? 1 minus cos squared of what? Of x. All right. So with this, we can expand, simplify. We are almost there. That's all right. Let us just expand here and collect the like terms. The numerator, 2 cos squared x minus 1 plus cos squared of x. Then we expand the bracket by 3. 3 times 1, that's a positive 3. 3 times negative cos squared was going to be negative 3 cos squared of what? Of x. Everything over what? We do the same thing in the denominator. We expand. So that was going to be 2 minus 2 expands the bracket. So that's negative 2. All right. Negative 2 times this negative was going to give you a positive. So that's 2 cos squared of x. So collecting our like terms, guys, this is 1 here. So 2 plus 1, that's 3. Minus 3, that was going to cancel. So the cos squared was going to cancel. So meaning to say in the numerator, you're going to be remaining with minus 1 plus 3, which is what? Which is 2. Everything over what? The denominator, also this cancel 2 minus 2. So you'll be left with what? Positive 2 cos squared of x. So this is it. 2 into 2, that's 1. Into 2, that's 1. So meaning to say this was going to give us 1 over what? Cos squared x. This is exactly what we had on our right-hand side. We have managed to prove that truly The left-hand side and the right-hand side, they are what? They are equal. So proof, guys, it's in your hands. It's just like simplify, but you have the answer already. All right? That is the proof. Simplify. Only that they gave you the answer. So you work out up to the answer that you're given. Then hence, determine. Hence, it's a continuation from what you just have proved there. Determine the value or values of x from 0 to 180, which will make the above identity undefined. When it is what? Undefined, this identity. We deal with the denominator is supposed to be equal to 0. K over 0, whatever that we have, the denominator is supposed to be what? 0. So instead of you working the left-hand side here, just use what? The right-hand side. Already there's something which is what? A single trig that we are given. So we're going to use 1 over what? 1 over cos squared of x, using that in simplest form. For it to be undefined, the denominator must be equal to what? Must be equal to 0. So this is it from the right-hand side, 1 over cos squared of x. For us to have this undefined, just like k over 0, the denominator has to be equal to 0, then we can solve. So if our denominator is equated to 0, it means we have what? Cos squared of x being equal to 0, just like that. Our denominator. This is cos squared. So what about cos x? Introducing the square root, but there is no effect because this is not affected. Cos of x, there is no plus or minus 0. 0 is just a 0, guys. All right. So if cos of x is equal to 0, what about x? From 0 to 180, we are not considering about the whole cycle, guys. This is from 0 to 180. If you understand your graphs, guys, from 0 to 180 degrees, where we have got 0, it is going to happen at what? Here, at 90 degrees. And that's 90 only, because this will be 180, this is 270, so it's at 90 degrees. You can take it from the graph. X is equal to 90 degrees, or use your calculator, arc cos 0, to find x. That's arc cos of what? Arc cos 0, which is what? 90 degrees. And that's equal to 90 degrees. According to the interval that you are given, there is no need of the general solution, guys. You're wasting your time there. From 0 to 90 or from 0 to 180, you can even tell the solutions where it must be found, in which region. So just use that reference angle as your solution. All right, so that was it. Our x is supposed to be 90 degrees for this to be undefined. 6.6, determine the value of this. All right, there they just want you to play around. There's something that they will be hiding that you just need to study here. All right, so that's 6.6 tan 1 times tan 2 and so on up to 89. Why is it that we do not have 90? All right, there's something here. 1, the last one, the first one and the last one. If we add these two, we're going to get a 90. 2 plus this, a 90 again. 3 plus this, a 90 again. So 4 plus that was going to be a 90 and so on. So, but there's one which is going to be limited in between. From 1 to 89, there's what? A tan 45. Because these are like pairs. Are you seeing, guys? They are pairs. So 45 won't have a pair because it's in between. So tan 45 will be left without a pair. It will be like tan, there will be what? Tan 44 here. Here there will be what? Tan 44. Here there will be tan 66. All right, so if we add, guys, where am I getting 66? Tan 46. So if you add those two, 44 plus 46, you get a 90 again. So it simply means, guys, it was a pair of multiplication that we had here. It was a pair of multiplication. Tan 1, let's take for an example of tan 1, because those angles, they are giving us 90 degrees, isn't it? So we just test tan 1 when multiplied to tan 89. This tan that we see is the same as sine over cos. So it is same as sine 1 over cos of 1 times tan 89. It is the same as the sine of 89 degrees over what? Cos 89. But these two, they're different, but they look the same in that difference. And guys, they never say it like even here. They just say determine even with a calculator, guys. Guys, all right, no problem. Let me do this one. Then the rest I'm going to use a calculator because here it's a waste of time what I'm doing here. But I just want you to see where it was taken from. Sine 1 over sine of over cos of 1 here. Since these two are not the same, like we cannot relate them to 1, it's 89, this is 1. But there's a relationship, remember, between cos and a sine. Cos of x, sine 90 degrees minus x from our cofactors, for cofunctions, I mean. The sine of x cos 90 degrees minus x. So if we're going to use that, this was going to be cos 90 degrees minus 89. 89, which is cos what? Which is what? Which is here, sorry, this one. From here. It was going to be cos minus 89, which is same as what? Cos 1. So it was going to give us cos of 1. The cos of 89 from this was going to give us a sine of 90 minus 89, which is sine of what? Sine of 1. So are we seeing that now these are the same? They can cancel. This one, same cancel, and that was going to give us a 1. This was happening throughout, of which we could have just used your calculator here to test what I'm talking about, because here we are not asked not to use our calculators, so we can use our calculators. Tan 1 times tan 89, tan 89 like this. All right, this is going to give us a 1. So we can see that the product of these two gives us a 1. So it is the same thing if we try tan 2 and tan 88. It was just a pattern which is repeating. Tan 2 times what? Times tan 88. Remember, 2 corresponds to 88. That was going to give us a 1 again. Are we seeing that? Even if we move on to 3 and what? 87. It's just a repetition. Tan 3 times tan 87. It was going to give us a 1 again. So it's a product of 1, 1, 1, 1, 1, 1, 1 throughout. For these pairs that we have, how many pairs are we going to have? That one is none of our simplification, even if we don't want to use that. Because we know, guys, that this whole concept here was going to be 1 times what? Another pair giving us a 1. Another pair coming up giving... guys, if you multiply 1 times 1 times 1, you just get a 1. But all these, they were going to continue for any times, for the number of times that you're given in between these. And remember that between tan 44 up to that one, tan 44 and tan 46, between there's a tan 45 which will be left with no pair. Tan 44 times tan 46. Again, it was supposed to give us what? A 1. Then at tan 45, it will be left alone, this one. So you're going to multiply up to 1 by 1 by 1 by 1 by 1 up to a condition where you have got what? Tan 45. In between. Because these are pairs. But tan 45 does not have a pair. But lucky enough, guys, tan 45 is equal to 1. So this one was not going to even change anything because tan 45 is what? It is 1. So this was just going to be 1 times what? Tan 45, where tan 45 is 1. So that's equal to what? That's equal to 1. So the to determine this value, this whole part, it was going to give us a 1. If you multiply these terms, you get a 1. So it's a study type of a question. You study what you're given, what exactly is happening, then you use that concept to answer. It might not be the same as of another question, but the idea remains the same. Study the concept behind the given question. Then you can attempt the question that you're given there. Question number 7, they gave us something on our triangles, and there's 7.1. In the diagram below, ABC is an isosceles triangle. ABC, all right? That triangle is isosceles, all right? That's 6 here and 6, all right? These two sides, they are equal, all right? With AB equal to BC 6 units, and another part is given also being equal, BD and AD. From B to D, this side, it is the same as AD, this side, all right, which is what? 4 units. And angle C is given as what? As alpha. From this information that we are given, 7.11, show that angle ADB is what? 180 minus 2 alpha. ADB. All right, let's show that. This is our diagram here. And we want to show that on 7.11 that ADB, angle ADB is equal to what? 180 minus 2 alpha. All right, so what can we do here? What can we do? We need to show this. ADB, that is the angle given on our diagram here. This is where we have got our ADB, this one. ADB. Okay, let's start first from the outer triangle ABC. Remember, we're told that AB and BC, they're equal. So it simply tells us that the angles opposite these sides should be equal. Opposite AB this side. The angle opposite, it's what? It's alpha. Opposite this ABC, the angle opposite in the bigger triangle, in the outer triangle ABC, the outer triangle, the angle is what? The angle is B. The angle is A here. The angle is A. So simply, angle A is equal to what? To angle C, which is what? Alpha. The reason being what? These are angles opposite what? Equal sides. Opposite what? Equal sides. The two sides are equal. So those angles opposite must be equal. So meaning to say, angle A, it is alpha there. But remember, they told us also about the inner triangle here. The inner triangle where it is the same, the angle, the length BD and the length of this one AD. They told us about this triangle, the inner triangle. So from triangle ABD, it simply tells us from those sides which are equal, the angle alpha here at A is the same as the angle there at what? At B. So that is angle ABD is equal to alpha as well. All right. So the reason being what? The same reason like what we saw before of what? Angles that are what? Opposite, equal what? Equal sides. This side to this angle, this side to this angle. So that's it. So here, the first one, it was because of sides AC and what? And side AB. It was because of side AB being equal to side AC. This second one, we are talking about the same reason of angles opposite what? Equal sides. But the sides that we are talking about here is what? These ones inside of triangle ABD. So we are referring to the sides AD and what? BD. From AD is equal to what? To BD. So this is it. So if our angle B is alpha and our angle A is alpha, we can determine the angle at D, which is what? The one that we need, ADB. So therefore, angle ADB is going to be equal to what? Angles in a triangle, remember they add up to 180 degrees. So it's going to be 180 degrees minus the sum of these two angles, alpha plus what? Alpha. So alpha plus alpha is going to give us what? 2 alpha. So that's it. We are referring to angles in a what? In a triangle, sum of angles in a triangle, adding up to 180 degrees. So that's it. We were asked to show that. So that's it. We have shown that these two are exactly the same. Hence, it's a continuation from what we have just shown. Now determine or calculate the value of cos 2 alpha. All right, cos 2 alpha. Okay, ADB is this one, ADB. All right, so let's see what's happening there. This is ADB. We just calculated this. This is 180 degrees minus what? 2 alpha, like this. So that's our angle ADB. And the question needs us to determine the value of cos 2 alpha. Are we seeing that it's a sketchy thing here? They are just playing around with us. They are just playing around because we have already a complete triangle from triangle ABD. Everything is given. The sides, all the sides are given. So remember from our cosine rule, that's the cos of a certain angle when it is given. All right, so here they gave us the problem is that you are given this formula. But guys, for those who understand, you can make cos of A the subject of the formula. All right, or you can just write your formula if you understand it, guys, that the cos of an angle, since we are to prove a cos, let's work with the cos than to say sine of this over this sine of, maybe we can end up with that angle at the end. We just have to try. But cos was just direct because already your answer, they say determine the value of cos this. So it's already having a cos. So the cosine rule states that for an angle A, the cos A is equal to B squared plus C squared minus A squared over 2BC, where B and C are the sides creating the angle A, and A squared is the side opposite that. So meaning to say the cos of the angle, our angle is what? This one. This is our angle, 180 degrees minus 2 alpha is supposed to be equal to the B and C. Simply means the sides creating the angle, which is these two sides, 4 and what? 4. So it was going to be 4 squared plus 4 squared minus A squared, that is the side opposite to the angle that you mentioned here. These two, they are opposite to each other, angle and what? A side. So angle is this one. What is its side? 6. So you must subtract 6 squared over what? 2 times B and C, repetition of the same points, 4 and what? Same values, 4 and 4. So this is it. It's an equation. Let's try to figure out. Remember cos, they want cos of what? 2 alpha here. Cos of 2 alpha. There we have cos of 180 degrees minus 2 alpha, which from our cast concept, this lies in the what? In the second quadrant, 180 degrees minus theta, which is cos there, it's a negative. So it was going to give us negative cos 2 alpha, like theta, negative our angle there is what? Theta, 2 alpha. So that's negative cos 2 alpha is equal to what? We simplify our right-hand side because those are values that can be simplified on our calculator. So we can simplify this 4 squared minus 6 squared, everything over 2 times 4 times 4. All right, 2 times 4 times 4. So that was going to give us negative 1 over 8. Negative 1 over 8. This is negative cos 2 alpha. So to have the value of cos alpha, divide by negative. So negative, negative cancels. So therefore, we have got cos 2 alpha in this case as what? 1 over 8. It will be what? A positive. Just like that. So it was a play around type of a question, all right? Where you need to play around with the information. So that is what we have cos alpha. I mean, cos 2 alpha is equal to 1 over 8. So they will give you questions like this. Just try to play around as many questions as you can, and also for you to get other question papers similar to this for other provinces. Make sure that you do join the membership so that you won't miss any of the other revisions, because you're going to have a lot of question papers, almost all the provinces. As long we have got those question papers, we are going to work them separately. So make sure that you become part of the family, Maths Zone African Motives, so that you do not miss any of the important revisions that you're going to have to prepare yourselves for the final exams that you are going to have. It starts with the March test. It is part of your marks, part and parcel of your SPA. So if you don't consider that, it's going to affect your SPA mark. Make sure that you have a greater mark for your SPA. That can help you in your finals, all right? So that is it, guys. Till we meet again.